Hello, math friends. Welcome to A Squared Math and Stuff. In this example, we are going to take a look at something called the rationalizing technique when calculating the limit of a function. Remember that we always want to directly substitute what our variable is approaching. In this case, we have z approaching 0. So let's just plug in 0 and see where it takes us. What do we get? So 7 minus 0 minus the square root of 7 all over 0. When we simplify this down, we end up with 0 over 0. And if you recall, this is our indeterminate form. And when we have an indeterminate form, it's a clue that we need to somehow simplify the original function. In this case, because we have some square roots in here, what we're going to do is we're going to rationalize the numerator. So we will rationalize and then simplify in order to calculate the limit of this function. So rationalize first, and then we will simplify. So the first thing I'm going to do is I'm just going to take a look at this function and rationalize it. I'm not even going to worry about the limit to start off. So let's take a look at just rationalizing the square root of 7 minus z minus the square root of 7, all divided by z. If you recall, when you rationalize a square root, or rationalize numerator or denominator, we work with the conjugate of what we want to rationalize. So we want to rationalize the numerator here, and the conjugate would be to change this minus sign to a plus sign. So let's go ahead and do that. We will then multiply both the numerator and the denominator by the conjugate of square root of 7 minus z plus the square root of 7. And we need what we do to the top, you have to do to the bottom. And this is what we have. So let's distribute all the way through for both the numerator and denominator. Well, actually in the denominator, I'm not going to distribute. I'm going to keep this as two separate terms that are just multiplied together. Because again, we are looking to simplify things. So hopefully something is going to cancel out here. All right. When I distribute through here, we end up with the square root of 7 minus z squared plus the square root of 7 times the square root of 7 minus z minus square root of 7, square root of 7 minus z, and then minus the square root of 7 squared, all divided by z times that square root of 7 minus z plus root 7. And the purpose of the conjugate is to get things to cancel out. So the purpose of this conjugate was to get rid of these middle terms. And we are left with then the two values that are squared. And once we square these, we drop the square root. We then have 7 minus z minus 7, all divided by that denominator. So let's keep this as two separate terms here. So 7, square root of 7 minus z plus the square root of 7. These 7's in the numerator cancel. We then have negative z, oh, that's a big z, divided by z times square root of 7 minus z plus square root of 7. And now we can cancel the z's. And we are finally then left with a negative 1, all divided by the square root of 7 minus z plus the square root of 7. So this is the conjugate that we will work with. So let's go ahead and box this off so I don't lose its placement and what we're working with. And I'm going to now go back to our original equation that we're finding the limit of as z approaches 0, and we're going to work through that. So let's go ahead and come down here, And we will start from the beginning. Let me write out the equation, and that is the limit as z approaches 0 of the square root of 7 minus z minus the square root of 7, all divided by z. So what I'm going to do is I'm going to use direct substitution because we already calculated this conjugate. So I'm going to directly substitute this in for my new, or for the original equation. So we will then have the limit as z approaches 0 of -1 all divided by the square root of 7 minus z plus the square root of 7. And so because we know this is as simplified as it's going to get, we can use direct substitution and plug in that 0 for z and start calculating this limit. So we are no longer going to write the limit as z approaches 0 because we are substituting in. So we have -1 divided by the square root of 7 minus 0 plus the square root of 7, which gives us -1 over 2 times the square root of 7. Still can't have root signs in the denominator, so now we have to rationalize again to get rid of that 7, the root 7. So doing that, we end up with a final answer of a -√7 all divided by 14. So that is our limit of this original equation. So again, when we have something that has square roots and you end up with your indeterminate form, rationalize either the numerator or denominator, whatever you need to rationalize, substitute that in for the original equation, plug in your c value, work your way through, and then you'll calculate your limit. If you like what you saw, go ahead and click that subscribe button, and I will chat with you later.